Welcome to the Pilot Forge. We are going to do some more navigation, and this time we will cover wind components. Why is wind important? It's a very simple thing. It's part of your everyday flying. We have taken a look at directions and the many varieties of it. We have also taken a look at distances and how to measure them. Now, when you put those two together, you have a particular distance in a particular direction that helps you get to your destination. But unlike a car, bus, train, we do not travel on the ground. We travel in relation to the ground, but in the air. And in the air, you will experience wind. Now, the wind has the power to displace you. In that, it can slow you down, it can speed you up, or it can shift you from the track, either side. Let's take a look at it one by one. Now, what we have here is our nifty little aeroplane traveling from here to here at 100 knots of indicated airspeed. Okay. In a nil wind situation, there's no wind, therefore your airspeed and ground speed will be the same. That means that your aircraft will travel 100 nautical miles per hour across the ground. In a headwind situation, the wind is coming from in front of you, so it is going to provide a resistance. It will slow you down. What it does is it takes away from the indicated airspeed. Therefore, your ground speed is less. Okay? By how much? Exactly the amount of the wind. So 100 knots minus 10 knots, ground speed is 90 knots. You will cover less distance in a headwind. In a tailwind, it is a pushing effect. It adds to your indicated airspeed. Therefore, you end up traveling a larger distance. Now, how much? 10 knots added to your indicated airspeed to give you 110 nautical miles per hour. Okay? Headwind takes away from the airspeed, and tailwind adds to the airspeed. Make sure you remember this for the rest of your life, okay? Now let's talk about crosswinds. To help us understand crosswinds, what I've got is a little bit of a diagram. Let me explain what I've drawn up. Runway direction of 360, which is pointing this way. Now for all intents and purposes, unless I specify, the top of the board will always be north. So north is also represented as 360. So 360 traveling to the north. You can also see that wind A is coming in from the north, 000 degrees at 20 knots. Now, what is a crosswind? A crosswind is effectively a wind which is at 90 degrees to the direction of the runway, which means either this or this is a crosswind. Alright, but are these the only two types of winds we can get, a headwind or a crosswind? Obviously not. We can get winds which are here too, C or B. With winds pertaining to C or B, there is always an element of a headwind and a crosswind in them. How? Anytime the wind does not flow down the runway, there is always an element of crosswind. Alright, but to understand that, what we need to realize is that wind is always a vector. What does that mean? What does a vector mean? A vector is something that has direction and magnitude. In this case, direction given by degrees, magnitude given by knots. Using this diagram, I will explain to you how to calculate your crosswind and headwind, because when we want to take off, the headwind is more important to us, but the presence of a crosswind means that we have to make some corrections and account for the crosswind as we take off. Okay? So, we've taken the runway 360, traveling north. So, this is our direction of travel. From the diagram itself, we can see that the wind coming along A is the ideal wind. But for purposes of explanation, we are using the wind C, which is 330, 20 knots. Now this is the representative of the wind at sea. Alright. We want to find out what our crosswind and headwind components are. So remembering that winds are vector in quantity, we can resolve them into the two components, which is the crosswind and the headwind. So crosswind is over here, headwind is over here. Alright. Now you can see this is a 90-degree triangle. We can apply basic trigonometry over here. Now remember, 8th, 9th and 10th standard, you asked why trigonometry is important. This is why. It does get used. Okay. The angular difference between the runway, that is 360, that direction of travel, and where the wind is coming from, that is your angle. That is your theta. Now, the difference between the two is what we will use in our sine and cos formula. How do we use them? Crosswinds are given by opposite. So opposite to the angle is your crosswind. Opposite upon hypotenuse giving you V sine theta. Simple. And headwind is this component adjacent to the angle. Therefore, adjacent upon hypotenuse giving you V cos theta. What is V? V is the maximum speed of the wind. Alright. Now that's how you get crosswinds. But are crosswinds only present during takeoff and landing? Obviously not. They are present when we fly. So we need to figure out how to compensate for crosswinds, which is done by understanding drift. What is drift? Everybody gets confused with drift, but it is not something to break your head over. It's a very simple thing. Drift is what happens when wind interacts with your aeroplane. Remember, we're not traveling along the ground with wheels stuck to the ground. There's no friction that is stopping us. So when a wind blows, the aeroplane gets displaced in the direction of the wind. Okay. Now, if there was no wind whatsoever, we would fly from here to here comfortably. We've seen that. But what if there is a wind from here? If we were traveling on this particular path and the wind was from here, we wouldn't be able to maintain this track, right? We'd get pushed. This is called drift. Same thing with the wind from here. If we were flying along here, what would happen? We'd get pushed this way, or we would drift along with the wind. Now, we need to ensure that we don't get drifted by the wind, because if this is our track and if A is here and B is here, ending up over here is not going to be useful. What if this distance was over 300 nautical miles? Not useful, right? So, what do? We apply a drift correction, or we hold the drift. What does that mean? Simply speaking, if we are traveling along this path and this is the wind we are experiencing, to stop the aircraft moving that way along with the wind, we have to turn our aircraft into wind so that we can compensate for that drift. Now, what does it mean? I am holding that drift. How am I holding it? By turning or heading my aircraft into the wind. Remember this, turning or heading the aircraft into the wind. This will allow me to have a track which is desirable. So I'll go from A over here to B just by changing my direction a little bit, but following the track that I had planned. If I don't, if I just fly like that, I'll get pushed away. Not desirable. Similar in this situation. Where do you think we will have to head? That will allow us to hold the drift as we fly from A to B. Okay? What type of drift are you holding? That also needs to be explained, right? Now, in this situation, there's no wind, so we don't need to hold any kind of a drift. In this situation, if we did not correct for the wind by turning our aircraft to head into the wind, what would happen is we would get drifted off to the left. So, by turning our aircraft into the wind, what we are doing is we are holding the aircraft from drifting to the left. We are holding left drift. Simple. Left drift is also called port drift. In this situation too, if we did not correct for the wind, we would get blown to the right. So, what we are doing is we are holding right drift. We are stopping. We are holding the aircraft from drifting off to the right. This is right drift. Right drift is also called starboard drift. To summarize drift, if our right wing is out and we are holding the aircraft from drifting off to the right, we are holding right drift or starboard drift. If we are turned to the left and holding the aircraft from drifting off to the left, we are holding left drift. Left wing in front of the right wing. Left drift is also called port drift. And in this situation, no drift. Another thing to remember, see the heading? The aircraft is pointed to the right of the track. That is left drift. Aircraft is pointed left of the track. So there is right drift. Now, this explanation is where you get confused. So, what do we remember? If we are stopping ourselves from being blown left of track, we are holding left drift. If we are stopping ourselves from being blown right of track, we are holding right drift. One more thing I'd like to talk to you about is the fact that drift is very significantly dependent on your wind direction and wind strength and also the speed at which you travel. Now my nifty little single engine aircraft is going to travel at a limited speed. So the angle of drift I will need to hold can be large. But introducing our new plane, the faster we fly, the lesser drift we have to hold. So in this case, the drift might be that much. Okay? With this, we have now learned that winds can make us go faster or they can make us go slower. They can also drift us left off track or drift right off track. But winds can also make us climb in an updraft or descend in a downdraft. But updrafts and downdrafts don't change our track, they change our altitude. It is important to know, but we will cover it in more detail when we cover meteorology. All right?